Hi. Today we're going through the grounding lugs, grounding and bonding of the modules and the module racking. We put the antioxidant compound on. We make sure that all the lugs are proper and tight. It is a tin-coated copper lay-in lug with a stainless steel set screw. Then we just climb around the whole array and check every one of them and make sure they're right. It's important. It's important to get rid of voltage if there's a nearby lightning strike. You don't want your panels or your electronic equipment to have increased voltage without, being able to get rid of it. So every PV system has one specific conductor that can carry all that excess voltage away. Now nothing can withstand a direct lightning strike that I know of, especially not solar modules. With the grounding electrode conductor in place, we can safely carry away all of that voltage in a short amount of time, especially for this area, because we're not really a high lightning prone area. It's not like Florida or other regions of the country, but it's very important. Okay, all of these new technologies are new. The equipment is new, the installers are new at it. The technology has been developed. Material science has developed so that they can make some of these products. And then you get into the code issues, electric code, plumbing code, etc. Even the code-making bodies are adapting and changing, because it's hard to write a standard or a code for products that are brand new, because there's so many different aspects or potential installations to consider. Is it a residential or commercial? Is it in somebody's attic? Or is it on the side of the house? Is it outside? And so as these technologies begin to be, deployed, let's say, or employed, what they find is that they keep having to change the rules. When things go awry, there's an investigation. They look at it. They figure, okay, well, if we were to write the code a little differently, it'd be safer. And so the photovoltaic section of the National Electric Code has been around since 1984. That was the first year that they had Article 690. And even though it's not technically official yet, the 2014 code is going to be the very first code that answers the question of phase imbalance, and they put a percentage at it. So, but they have other changes as well. Sometimes they add something into the code concerning PV, and then the following code cycle they remove it. Sometimes they figure this is the way to go, and then they say, okay, well, it really doesn't have the desired beneficial outcomes, so maybe we can relax the standard a little bit. And then sometimes they get ahead of themselves. They put something into the code and they don't even have the equipment made. Maybe it's technically possible, but you still have to find a manufacturer that can get it listed or recognized by a national testing agency, such as Underwriters Laboratories, etc. So anybody or firm that undertakes a project like this goes through a gigantic learning curve. The contractors learn, the installers learn, everybody learns, and then they find out what they can do, or maybe a smarter way to do it. And so I say that, Robert Scarano's got a pretty decent feather in his cap for this one, because this building's got everything, and it's in an area that's, city, and we need more buildings like this. We need them all over the place. And if you could take an empty lot that's not doing anything good for anybody, turn it into a nice building like this that doesn't hog our natural resources. Yeah, anybody that can do it should be doing it. In this case, this particular building, at the moment, creates electricity on its own. It's the solar electric panels with the inverters. Makes electricity. The building uses all of that electricity first, and any excess that's available gets sent into the grid. And then that house and the neighbor's house and these guys over here all can benefit from using that electricity, and the utility doesn't have to make electricity 100 miles away, send it through utility lines to get over here, and it's pretty wasteful. So distributed generation is what the utilities call it, and utilities love it. They love distributed generation. It solves a problem for them. If they could have distributed generation systems like solar electric or wind electric, for lack of a better word, distributed in certain areas of the grid, they may not have to upgrade the grid. They may not have to put larger transformers in or take down utility lines and put up bigger ones. They can keep what they have. So it's also better. These systems operate with nearly 100% power factor. To put it in perspective, normally the grid at a house is not much better than 85% power factor. So if these systems are putting out 100% and going to the neighbor's house, that neighbor is getting a much better quality of power. All of his inductive machinery is going to run better. His air conditioner is going to run better, more efficiently. His ceiling fans, even the hair dryer, that's going to run better. So it's just a benefit all around.